Madam, make me host, madam.
Good evening, sir. I made you host, sir.
Down. Okay. Yeah.
Good evening, sir.
Yeah. Good evening.
Sir, you can start now.
Yeah. Hey, Sajay, how many problems you have completed on that day based on Prism? This is also completed, I think. Yeah, we have to do this, right?
Yes, sir.
Yeah. Yes. Look at this problem. Look at this problem. What is given? There is a prism of what apex angle?
So 4 degrees.
4 degrees. And what is the refractive index?
So 1.5.
1.5. That is located in the in front of the vertical plane mirror.
Sir, you are not audible, sir.
Yeah. I think now it's fine. Yeah. Refractive index is 1.5. Apex is in front of a vertical plane mirror, right? This is the vertical plane mirror, Ajay.
Yes, sir.
Now they are asking you to find through what angle. Through what angle is the ray deviated after reflection from the mirror?
Yes,
What is the formula for the deviation? Actually, here two phenomena is taking place, Ajay. One is the refraction through prism. For the prism, you know, the deviation for the prism is given by the formula. For thin prism, the deviation is given by the formula n
so n
minus
minus
1
1
into.
into A, sir.
Correct, no?
Yes, sir.
Yeah. And also there is deviation by the plane mirror, right? For plane mirror deviation is 180 minus 2i. Very angle 2
Sir.
minus 2 theta will be the deviation for.
Sir, your voice is breaking, sir.
Hello, can you see the screen sharing?
Yes, sir.
Okay, some internet issues, I think. Sorry for the inconvenience. Yeah. Now they are asking you to find the total deviation, right?
Yes, sir.
So here deviation is taking place because of the prism and also because of what? Plane mirror.
So plane mirror.
So what is the deviation formula for the prism?
Sir, n minus 1 into a.
Yeah, what is the refractive index they have given? This is
So
1.5
1.5.
minus 1
Yes, sir.
into A. What is A?
So 4 degrees.
4 degrees. So this is how much? 1.5 minus 1? 0.5. 0.5 into 4 means 2 degree.
So 2 degree.
For mirror deviation is given by 180 minus 2i. So 180 minus 2i. 2 into what is the
Sir.
angle of incidence for plane
Sir.
mirror?
Sir, 2 degrees, sir.
2 degrees. So you simplify this. 180 minus 4 degree, that is equal to how much?
So 176 degree.
176 degree. Now you have to find what is the total deviation, right?
Yes, sir.
What is total deviation, Appa? Total deviation is nothing but deviation due to prism plus
Plus the
the
deviation due
deviation due to
to
mirror.
Yes, sir.
This is equal to how much? 2 degree
So 2
plus
degree.
176 degree.
176, sir.
How
So
much it is?
178, sir. 178, sir. Option C.
178 degree. So which is the right option?
Option C. Option C, sir.
178 degree. So which is the right option?
Option C.
Got it?
Yes, sir.
Yeah. Look at this. Look at the next problem. A ray of light is there that is incident on the hypotenuse of a right angled prism, right? And it is parallel to the parallel base inside the prism. Mu is the refractive index. What is the maximum base angle they are expecting for which light is totally reflected from the hypotenuse? They are expecting you to find alpha. They're expecting you to find what?
Sir,
Alpha. Yeah. So what is the critical angle here? Look at the diagram and tell what is the critical angle. Critical angle is this, no? For which reflection is taking place. So
Yes,
critical angle is equal to what?
Sir, 90 minus alpha.
90 minus alpha. Correct, no?
Yes, sir.
Yeah. Now, how do you define the sin C in terms of n? Or I can take sin on both the side. Sin C is equal to sin of 90 minus alpha. So sin C is equal to sin of 90 minus alpha is what? Cos
Sir,
alpha.
cos alpha.
You know how the sin C and the refractive index are related, right? Formula. Sin C is
Yes,
equal
sir.
to 1 divided by refractive index, no?
Yes, sir.
So 1 by mu is equal to what?
Sir,
Cos.
cos alpha.
Cos inverse of 1 by, what is cos inverse of 1 by mu? Alpha. So what is the base angle alpha? What is the base angle alpha? Cos inverse of 1 by mu.
Yes, sir.
Hello. Madam, just now, madam, make me most. No, I'm getting host disabled participant screen sharing. Now it is making most. Yeah. Some internet problem, I think, madam, today. Yeah. Students, can you get the screen sharing now? Hello, students?
Yes, sir. Yes, sir.
Yeah. So if I shift that cost to the LHS, from where you are not get the steps?
So from that 1 by
Yeah.
1 by
Correct.
refractive
Yeah.
index is equal to cos
So you
alpha.
know that sin C is equal to the reciprocal of refractive index, no?
Yes, sir.
So 1 by mu is equal to what? Cos alpha.
So cos alpha.
Yeah, if I shift the cos to the LHS, it becomes what? Cos inverse of 1 by mu. Cos inverse of 1 by mu. That is equal to alpha. So mu, 1 by mu is cos inverse. That is alpha. So they are expecting the base angle only, no alpha.
Yes, sir. So
So what
answer
is
will be
the base
cos
angle
inverse of
alpha
1 by
equal
mu.
to? Cos inverse
Cos
of
inverse of
1
1
by
by
mu.
mu, which is option D.
Yeah. Look at this. There are two prisms here. One is flint glass prism, the another one is crown glass prism that is producing dispersion without what? Deviation.
Deviation.
Yeah. There is no deviation means deviation produced by the flint glass plus deviation produced by the crown glass must be equal to what? Zero, no.
Sure, zero, sir.
Because they are telling that there is no deviation at all. So when you don't get the deviation for the flint glass plus deviation of the crown glass must be equal to 0. Yeah. Now, what is the angle of the prism of the flint glass they have given?
Sir, flint glass is 1.60.
What is the angle of the prism of the crown glass? You have to find.
Sir.
Angle of the crown glass. What is the refractive indices of this? Refractive index of the flint glass is 1.602.
And for the
Refractive index of crown glass is 1.5. Yeah. Deviation formula is given by the formula n minus 1 into a, right? This is with respect to flint. Plus refractive index of crown glass minus 1 into angle of the crown glass prism is equal to 0. Refractive index of the flint glass prism is how much? 1.602, no?
Yes, sir.
What is area of the flint glass? Angle of the flint glass?
Sir, 10 degrees.
10 degree. Crown glass refractive index? 1.500 minus 1. What is the angle of the crown glass prism? You have to find. Can you simplify this?
Yes, sir.
Can you simplify this for me? Yeah. This is 0.602 into 10 degree plus 0.5 into AC. This is equal to 0. 6.02 plus 0.5 into AC equals to 0. So what is the angle of the crown glass prism? Minus 6.02 by 0.5. So 6.02 by 0.5 is how much?
Sir, 12 point.
Yeah, 12 degree, or you can say 12.04 degree, right?
Yes, sir.
12.04 degree is nothing but 12 degree 2.4 minutes. You know how to simplify that, right?
Yes, sir.
You know that 1 degree corresponds to how much?
So 60 minutes.
So you want what is for 0.04 degree, right? So 60 into 0.04. What is 60 into 0.04? 2.4.
2.4, sir.
So 0.04 degrees, 2.4 minutes. Please remember this. So 12.04 degree can be taken as 12 degree plus 0.04 degree. No. I will keep this 12 degree as it is. This 0.04 degree can be written as 2.4 minutes. 2.4 minutes. So 12 degree, 2.4 minutes is the area of, angle of the crown glass prism. So that is option A. But you can also observe one more thing here. That is minus we are getting, right?
Yes, sir.
What is that negative sign indicates? Negative sign indicates that the angle of the prism should be reversed.
Yes, sir.
So if I say this is the flint glass prism with angle A, this should be the angle of the crown glass prism. So angle of the prism should be reversed. So that is the meaning of this negative sign. So what is the area of the crown glass finally? 12 degree to 2.4 minutes. So which is the right option? Option A. Any doubt in this problem?
No, sir.
Okay. So these are the problems on the refraction through prism. Yeah. Shall we go to the next, this thing? That is refraction through a spherical surface. How the refraction is going to take place through spherical surface. Yeah. So here you have studied the refraction through plane surface and you have studied the refraction through the prism. Now in this session, we'll take up the refraction through what? Curved surfaces. Okay.
Yes. Yes, sir.
Look at this. If I consider one spherical surface, this is the center. See, in this spherical surface, I'm going to consider a small portion here. I'm going to consider this small portion where the refraction is going to take place. This small portion is what we call as an aperture. We are considering an aperture, and I'm going to consider only this portion now. That is this. This is the portion. This is what we call as the spherical surface or a curved surface. So similarly, this is the curved surface. So in this spherical surface, whatever the midpoint is there, the midpoint of this P is called as the pole. The midpoint of the curved surface is called as what?
So
The pole.
pole, sir. Pole.
Yeah. If I place the object here, what is O represents? What is O represents?
So, center of
Object.
curvature.
Now,
Sir.
I will measure the distance from the pole to this object.
So,
Ah,
so in this curved surface, sir.
ah.
So inside the surface also refraction will take place, sir.
Inside the spherical surface only the refraction is taking place.
So like it takes place at this first surface, right, sir? So that
No. If you consider this small portion here, if you place the object here, the ray of light will pass and the refraction will take like this. If the object is placed inside the spherical, the object is here, the refraction takes place here. So in both the sides, the refraction can be possible.
yes, sir.
Are you getting my point?
Yes, sir. Yes.
So in which medium the object is placed, that is going to be important. Look at the two diagrams. In the first diagram, object is placed outside, no?
Yes, sir.
In the second diagram, look at, if I complete this spherical surface, here object is there, which is inside of the spherical surface, no?
Yes, sir.
So in both the surfaces, in both the mediums, the refraction can take place. Then, if the object is placed in the first medium, image will be formed on the other medium. So what is I represents here? Image.
So image.
Distance from the pole to image is called image distance, V. What is V stands for?
So image distance.
Image distance. If I take object distance as U, object distance as U, if I take that medium as N1 and N2 as the refractive index of the image medium. N1 is the refractive index of object medium. N2 is the refractive index of the image medium. Okay. Now, let me consider the situation like this. What is this called? What is this AB called?
So that's the curved surface, sir.
Curved surface. What is the midpoint of this curved surface
Pole,
called?
sir. Pole.
Pole. For this curved surface, center of curvature lies right side or left side?
Sir,
For this
right
curved
side, sir.
surface
Right
AB,
side, sir. Right side, sir.
center of curvature lies right side or left side?
Sir, right.
Yeah, right side, no.
Yes, sir.
So this is the center of curvature. Okay. Now, I'm going to join the line from the pole to the center of curvature. Actually, this is called the principal axis. I will consider this medium as N1 and the refractive index of this medium as N2. Got it, Ajay?
Yes, sir.
Yeah. Now I'm going to place the object in N1 medium upper O. What is O?
So object.
O is the object? No.
Yes, sir.
O is the object? No, sir.
Yes, sir.
Okay. What is pole to object distance called?
So U.
U. From pole to image, if I say the image formed somewhere here. Yeah, Dhanalakshmi, can you tell me what is the distance from pole to image? Image distance, no. Yeah. Ajay, what is the distance from pole to curvature called?
So pole to image distance, sir. V, sir, represented by V. So pole to center of
Yeah.
curvature is
Pole to see?
so
Radius of curvature.
Radius
Yeah.
of curvature.
Yeah. Got it, Varsha?
Yes, sir.
Yeah. Now, if I take the ray from the object, if I draw the normal, usually normal is drawn from the center of curvature. The refraction takes place, that refracted ray will meet the image here. Refracted ray will meet the image there. Yeah. Now, there is a relationship between N, U, V, R. What is that relationship between N, U, V, R? Please remember this, minus refractive index of object medium by object distance. What is object distance here? U, plus refractive index of image medium, that is N2, by what is the image distance? V. That is equal to refractive index of image medium minus refractive index of object medium divided by the radius of curvature. So please remember this formula. What is the formula for the relation between NUVR? Or what is the refraction formula for curved surface? For curved surface, what is the formula we have? Minus N1 by
So
U.
minus N1 by U plus N2 by V is equal to N2 minus N1 by R.
Yeah. You have to use this particular formula for the refraction through spherical surface. So you have to make use of sign convention. You have to use the sign convention here also while solving the problems. Convention, which you have studied the same convention in the case of mirror. In the case of convention, whatever the sign convention you have studied in mirror, you have to use the same type of convention in the curved surface also. Got it?
Yes, sir.
Yeah. Come to the next concept, that is lens. Look at the definition. What is a lens? Bounded by how many surfaces?
So two refracting surfaces, sir.
Two refracting surface. In that, at least one surface must be spherical. One surface must be spherical. Now, if I take both the spherical surface like this, or the surface, curved surfaces will be like this. Both are curved surface here. This is plane. This is curved surface. This is plane. This is curved surface. So here I have written the different types of lenses, my dear. Ajay, can you tell me what type of lens it is, the first one?
So biconvex, sir.
It is a biconvex lens or simply a convex lens where the thickness at the center is large
Yes, sir. So
compared to
second
the
one is second one is
edges.
biconcave lens.
Edges, the thickness is less. Second one, thickness at the center is less, but at the edges it is more. It is considered as a concave lens. So one is convex lens, the second one is concave lens. Since the thickness at the center is more, this is called convex, and the other surface is plane.
So plano
Other
convex,
surface
sir.
is plane.
Plano
Very
convex.
good, very good. Yeah, it is plano-convex lens. Here the thickness is less at the center, so it is a plano.
So plano concave lens.
Plano-concave. So the first one is called the convex lens. The second one is called the concave lens. The third one is called the plano-convex lens. The fourth one is called the plano-concave lens. Yeah. Now, come to this particular point. You can see the center for this, both the surface. This is the center, right?
Yes, sir.
This center is called as optic center, denoted by U. What is optic center? Optic center is a point inside the lens on the principal axis. Vector, it will undergo undeviation. The ray will not undergo deviation. Ray is undeviated. Whenever the ray of light is passed directly through the optic center, the ray will not undergo deviation. The ray will undergo with undeviated.
Yes, sir. So
Yeah, that is called the optic center. Coming to the principal focus. Can you tell me what type of lens it is?
so convex lens, sir.
It is a convex lens. The parallel rays are incident here. The parallel rays are incident here. As soon as the parallel rays are incident, it converges to one particular point. It converges to one particular point. Axis. In the case of a convex lens, the ray will converges to one particular point. What is this particular point called? Principal focus. In the case of a convex lens, the refracted ray will converges. But in the case of a concave lens, whenever the ray of light is incident like this, the ray will refracted like this. If you produce this refracted ray backward, you feel that the rays are diverging. So at this particular point, the rays are diverging. At this particular point, the rays are converging. This particular point called Ajay?
So principal focus.
So whenever the parallel rays are incident on a convex lens or a concave lens, it will either converge or diverge from a point. That particular point we call it as what? Principal focus. What is that called? Principal focus. Look at one more diagram. Can you tell me what type of lens it is?
So convex.
What is this point called? O.
Pole.
What is O? Optic center, no?
The optic center.
Yeah. If I incident a parallel rays, what will happen?
So
These
They-
rays are going to
they
be
will
converged to
incident
one
at a
particular point.
sir, they'll all meet at one point, sir, and that will be the principal focus.
Yeah. They will meet at one particular point. What is that particular point we called? Principal focus F. Now, what is O called? Optic center. What is F called? Principal focus. Then you can measure what is the distance from optic center to principal focus. That is usually denoted with small f. That small f is called as what?
Focal length.
Focal length. So what is the distance from optic center to principal focus? Distance from optic center to principal focus is called focal length. Okay. The reciprocal of the focal length. The reciprocal of the focal length is called the power. Reciprocal of what? Power of the lens. What is the SI unit of the power of a lens? It is diopter denoted by the symbol D. Yeah, diopter denoted by the symbol D. Yeah. One more you have to remember here. For convex lens, focal length is positive, right? Because ray is incidenting like this. Focal length is also measured in the same direction. So focal length and power of a lens is taken as positive. For convex lens, focal length and power of a lens both are positive.
Yes, sir.
But what about for concave lens?
Sir, they're negative, sir.
Because it will measure opposite to the incident ray. This here, this is F.
Yes.
This is ray is incidenting like this. Focal length is measured like this. Opposite, no. So focal length should be negative. The power of the lens is also what? Negative. So for convex lens, focal length and power of a lens are positive. For concave lens, focal length and power of a lens are negative. Any doubt?
No, sir.
Yeah. Very, very important concept. That is lens maker's formula. See here, if I consider a convex lens, this is the principal axis. I will place the object here. This medium is N1, lens medium is N2. This is once again N1, surrounding medium. Okay. Now, I will send the ray of light from O. Here the refraction takes place, right? For the first surface,
Yes, sir.
APB. For the first surface APB, the refraction takes place and the image will be formed somewhere here. Let it be I dash. Can we expect one more refraction?
Yes, sir.
Because lens is bounded by how many spherical surface?
Sir, 2.
Yeah. It is bounded by 2 spherical surface. So here once again I should get a refraction here. What is this called? Image. So this is called the image. Let us say F is the focal length of the lens. F is the focal length of the lens. R1 is the radius of curvature of the first surface. R2 is the radius of curvature of the surface.
So your voice is breaking, sir.
My voice is breaking. Yeah, I think there is some internet problem today, but due to rain. Yeah, and now?
Yes, sir, it's better.
Yeah. How many refractions will take place in the lens? 2
Sir, two.
refractions.
2, sir.
Yeah, on taking the equations and on simplification, you are going to get a final formula like this. 1 by focal length is equal to N2 by N1 minus 1 into 1 by R1 minus 1 by R2. So what is the formula you are going to get for 1 by F? You are going to get a formula for 1 by F. What is that 1 by F formula?
So 1 by F is equal to N2 by N1 minus 1.
N2 by N1 minus 1 into 1 by R1 minus 1 by R2. What is this formula called?
So lens maker's formula.
Yeah, lens maker's formula. Please remember, here also you have to use sign convention. Use sign convention while solving what? Problems. While using the problems, while using this formula in the problems, you have to make use of what?
So sign convention.
Yeah, sign convention. Please remember, this is the formula for the lens maker's formula. 1 by F is equal to N2 by N1 minus 1 into 1 by R1 minus 1 by R2. What is N2 here? Refractive index of the lens. What is N2?
So refractive index of the lens.
Refractive index of lens. What is N1? Refractive index of
the medium surrounding the lens.
surrounding medium. Very good. Surrounding medium. R1 is the radius of curvature of the first surface. R2 is the radius of curvature of the second surface. Yeah. Now, I will write one diagram here. Can you explain the formula for this? This is convex lens made up of with glass Ng. This is air. Okay. Can you tell me the lens maker formula for this?
So 1 by F is equal to
1 by F equals to
So Ng minus 1.
Ng minus 1. No need to write divided by Na because
Sir.
refractive index of air is what?
1, sir.
1. So no need of writing Ng by Na. So this is the focal length of the lens in air medium. Ng minus 1 into 1 by R1 minus
1 by R.
1 by R2. Where R1 and R2 the radius of curvature of the first surface and the second surface. Very good. Now I will write one more diagram, Ajay. This is lens. Refractive index of glass is Ng. Now I am going to place this lens in a water medium. Water medium. Can you tell me the lens maker's formula for this? Can you tell me the lens maker's formula for this?
So 1 by F is equal to.
I will wait. I will tell FW. Focal length in
Yes.
water. This is focal length in air. This is focal length in water. Which is equal to what?
So Ng by W minus 1 into 1 by R1 minus 1 by R.
Ng by NW minus 1. Ng by NW minus 1 into what? Into what?
So 1 by R1 minus 1 by R2.
Into 1 by R1 minus 1 by R2. Please remember, if I take the convex lens from air to water, if I take the lens from air to water, please remember the focal length increases by how many times? 4 times. Please remember that. Focal length in water is always 4 times the focal length in air. You can solve this because you know refractive index of glass is how much? 3 by 2. What is the refractive index of water?
So 4 by 5.
4 by 3. So focal length in water is always equal to how many times? 4 times the focal length in air. So whenever the lens is immersed inside the water, what happens to the focal length? Increases. If it is water medium, focal length will become how many times?
So 4 times.
Yeah. You know power and focal length are inversely proportional.
Yes, sir.
So if focal length increases, what happens to the power?
So decreases.
Yeah. So power of a lens is inversely proportional to the focal length. So as focal length increases, the power has to decrease. Can you tell me what is the change in focal length? Can you tell me what is the change in focal length?
So
Focal length in water
Sir.
minus focal length in air.
focal length
No.
in air, sir. Yes, sir.
So focal length in water is 4 times. So 4 times
Yes, sir.
minus 1 time means how many times?
3 times, sir.
So the 3 times is the change in the focal length.
Yes, sir.
3 times of FA. 3 times of the focal length in air. So this is how we are going to find the change in the focal length. So please remember, whenever the lens is brought from air medium to some liquid medium, the focal length will increases and the power will decrease. Suppose if the liquid is a water medium, if liquid is a water medium, then the focal length is going to increase by how many times?
Sir, 3 times, sir.
It increases by 3 times. Focal length becomes how much? 4 times of the focal length in here. So this is
Yes.
very important formula. Pa. What is this called? Lens makers.
So lens makers
Formula. Yeah. This is called the lens makers formulas. So this in curved surfaces, and so still there are 2 more concepts apart. So 3 more concepts. One is called the lens formula. The second one is called the magnification and cutting of a lens. How it is going to be undergoes the refraction. These 3 concepts I'm going to take in the next session. Okay.
Yes, sir.
So in the next session, we'll study the lens formula, magnification, cutting of lens. After discussion of this, immediately we'll take up the MCQs or competitive problems, objective problems based on lenses. Okay.
Yes, sir.
So I will stop at this point. Let me continue in the next session, students. Thank you.
Thank you, sir.
Thank you.